That computer you're currently watching this on is almost certainly made from materials transported in shipping containers from overseas. But what secures these containers to the ship? Hi, my name is Jess, and today, with the help of my team members, I present to you a product that will revolutionize the shipping industry, the Lashing 2000. From 2014 to 2016, 1,400 shipping containers fell off into the ocean. In fact, this year, APL England lost several containers off the New South Wales coast. The incident cost the shipping company over $20 million in fines and cleanup. But the environment bore the brunt of this mistake, as debris littered the oceans and washed up on beaches along the coast. The plastic debris can harm marine life, and paint chips from submerged containers may be toxic. Therefore, we must create better securing technology to protect the environment and save logistic companies millions. As you can see in the graph, the largest cause for cargo loss, according to Crew, are ineffective lashing bars. The current securing system uses steel lashing bars that are placed and tightened by hand, a process that is slow, ineffective, and raises OH-ness concerns. And they often fail and break under overweight load and extreme weather.
Our solution, Lashing 2000, seeks to revolutionize the current shipping container attachment system by providing innovative design solutions to three critical areas, these being efficiency, simplicity, and safety. Our solution uses an adaptation of the current locking turnbuckle lashing with the addition of a spring and damper that work in unison to provide an opposing force that restores balance to the system caused by the immense forces that can be experienced due to rough seas and strong winds. This allows our design to provide a consistent, even tension on the container no matter the extent of the prevailing weather conditions. The next feature of our solution consists of a series of mechanical gears that enable lashing to be tensioned and detensioned externally through the effortless, efficient operation of a hand wheel located on the deck of the ship. Our design allows for the lashing operation to be completed on 3 containers simultaneously, providing an approximate time reduction in the lashing operation per container in excess of 2.5 times. This solution will not only increase time efficiency, but also greatly improve the lashing operator's safety by dramatically decreasing the amount of time spent on the lashing bridge, located high up off the deck of the ship, exposed to many potential safety hazards and risks, for example, while applying tension to the current lashing setup. This is a simplified simulation of Lashing 2000. It depicts the operation of the mechanical gearing system and its effects of applying tension, replicated by the upwards motion of the lashing setup and the detensioning indicated by the lowering of the lashing setup.
There were many technical aspects our team looked at in detail to ensure that the Lashing 2000 system will function well on the ships and help the workers implement them. The main aspect to consider is the swaying of the ship because of the weather and waves, which create forces of up to 850 kilonewtons. Due to these high forces, and considering the system will be on a ship at sea, it is essential to use a material for the system that will have the strength to handle these forces, is cost-effective, as well as being non-corrosive to ensure the durability of the lashing system in ocean conditions so that they can be used for long periods. Stainless steel has a tensile strength of 860 megapascals, costs $2,000 a ton, and consists of at least 11% chromium that prevents the iron in the steel from corroding, hence making it a highly suitable material. The gear loop, wheel shaft, and worm rod will be produced from stainless steel using CNC cutting and milling machine. The lashing rod parts and shaft mounts are to be made through the hot forging of high carbon steel and galvanized afterwards. Similarly, the springs will be manufactured from the same material using a CNC forming machine and later galvanized. The Lashing 2000 requires a higher torque than what is practically achievable for the average person. Therefore, a torque step-up gear ratio of the system is required. We found that between the 4 gears of the system, there's an overall gear ratio of 10 to 1, meaning that 1 revolution of the handwheel will result in 10 revolutions of the lashing loops, with 9.3 revolutions of the handwheel required for a complete high chain cycle. Assuming that the average person can exert 600 newtons of force to the handwheel, this gives a torque applied of 192 newton meters. By further calculations, we found the resulting torque to be greater than 1300 newton meters, which is greater than the torque required by the lashing of 1000 newton meters to safely secure it to the containers and lashing bridge. As a result, the gearing system used in the Lashing 2000 design is optimized to provide sufficient torque while minimizing the number of complete revolutions required to tighten or loosen the lashing system. Our team has created a design that satisfies all the requirements to restrain the containers together and keep them from falling overboard while in the harsh sea environments. We've made the CAD models and completed the necessary calculations for the system and researched the manufacturing processes to find what is cost and time effective to ensure that it will be ready for manufacturing and hence ready to be used by our target customers in the near future. The design improves the current lashing system while also being simple and effective to allow the transition to the Lashing 2000 to be swift and easy worldwide. On behalf of Team 4, we hope you enjoyed our presentation and look forward to answering any questions you may have. Thank you.